The vertical milling machines, or mills, in the student shop are Tree Model 2UVRCs, equipped with Kurt vices and Sony digital readouts. In operation, a milling machine spins a cutting tool, such as an end mill, a ball end mill, or a drill bit. The spinning tool is brought into contact with the object to be shaped, called a part. The direction parallel to the axis of rotation of the tool is the Z direction, or the vertical direction. Holes can be drilled only in the Z direction. When facing the mill, the horizontal direction into or away from the mill is the Y direction. The remaining horizontal direction is the X direction. Cuts can be made in the X, Y, or Z direction. The part of the mill that holds the spinning tool and moves in the vertical or Z direction is the quill. The quill motion is restricted to the Z direction. The table that holds the part can be moved manually in the X, Y, or Z directions. The table also has an auto feed in the X and Y directions. End mills have different sizes and shapes for cutting different profiles in the part. The cutting surfaces on end mills are called flutes. The most common end mills have either 2 or 4 flutes. 2-flute end mills are best for cutting aluminum. Steel can be cut with either. A center cutting end mill, which usually has 2 flutes, has flutes that extend to the very center of the mill. It can be plunged into a part like a drill. Non-center cutting end mills have a hole in the very center of the mill. They can be used to enlarge an existing hole, but cannot be plunged into a part that doesn't already have a hole in it. Both types can be used to remove material from the part in the horizontal direction. Ball end mills have rounded ends. They are used for cutting rounded profiles or holes with spherical ends. A mill is held in place in the quill by a collet. The collet should be chosen as to be as close to the diameter of the end mill as possible, while still permitting the end mill to slide freely in the collet. The collet is held in place on the quill by a threaded retaining ring. Use extreme care when inserting or removing the end mill from the collet. If the end mill slips and falls against the table, it will likely chip and be rendered useless. The drill chuck, which holds drill bits, starter bits, and reamers, is attached to the quill with a collet in the same manner as an end mill. The drill chuck and drill bits are not strong in the lateral direction, so use them to make cuts in the Z direction only. Do not try to make X or Y direction cuts with them. A drill bit is placed in the drill chuck, and the drill chuck is tightened with a chuck key. The quill is raised and lowered with the quill downfeed lever. The lever position can be adjusted to any convenient angle by pulling out slightly on the lever, adjusting the lever angle, and then pushing the lever back in. The quill height can be locked into position by pulling down on the quill lock. The variable downfeed stop is used for making precision adjustments in the height of the quill when it is fully lowered. The scale is in thousandths of an inch. 3 wheels or hand cranks control the position of the table. The knee elevating crank moves the table in the Z direction. The Y-axis hand wheel moves the table forwards and backwards in the Y direction. The X-axis hand wheels move the table left and right in the X direction. The table can be locked in place in any of the 3 directions. To lock the table in place in the Z direction, pull the knee elevating crank out until the teeth disengage and lift up the Z-axis lock lever. To lock the table in place in the Y direction, pull the Y-axis hand wheel out until the teeth disengage, and pull the Y-axis lock towards you. To lock the table in place in the X direction, tighten the X-axis lock. Be certain that a direction is unlocked before engaging the auto feed in that direction. All three wheels or hand cranks have some play in them, so the crank can move a little without moving the table. The spinning speed of the mill has two ranges, fast and slow. Within either range, the speed is continuously variable. Faster is not always better. Important: only change the speed range with the motor off. Only adjust the speed within a range with the motor on. In general, for all machine tools, adjust discrete speeds with the tool off and adjust continuously variable speed with the motor on. To change the speed range to fast or slow, make sure the motor is off and then move the speed switch at the top of the mill. Fast is slanted to the left and slow is vertical. While switching ranges, you may need to rotate the quill a little to get the gears to line up. To vary the speed within a range, make sure the motor is on and turn the speed adjust knob. The digital readout on the mill can be used to determine the horizontal position of the tool relative to the part and changes in the position. However, you should always measure final dimensions with a micrometer or calipers, as the digital readout is not perfectly calibrated. Press the on button on the readout. Press the reset buttons for the readout to operate. The reset buttons will also set the readout to 0 for a given dimension at any time. You can also set the readout to a specific number. Press the button indicating which readout you wish to set, enter the desired number, and press the P button. The X readout and the Y readout display the position of the cutter in the X and Y directions respectively. The red lever on the top of the mill turns on the quill motor. To turn on the motor in the forward direction, pull the lever to the right. Then, the lever indicator points left to the fore indicator. To turn it on in the backward direction, pull it to the left. The lever indicator points right to the rev indicator. The center position is off. The handbrake on the mill will slow the mill down quickly when needed. Never use the handbrake when the motor is on. Small parts should be placed in the vise for milling operations. The first step in placing a part in the vise is to clean out any debris or metal shavings from the vise with a soft brush. Unnoticed metal shavings beneath spacers or parts have ruined the tolerance on many a project. Next, clean off any spacers or supports that are necessary. The spacers have two purposes: to raise the part up so that you mill the part and not the vise, and to leave a space below the part so that you drill the part and not the vise. Place the spacers in the approximate position, then place the part and tighten the vise to secure it. Secure larger parts directly to the table with a set of studs, nuts, brackets and spacers designed for that purpose. First, place one of the large nuts on the bottom of a stud and slide the combination into position. Then place one of the retaining brackets on the stud. One end of the bracket is serrated to mesh with a serrated spacer. Place a small nut atop the stud. Finally, place one of the serrated spacer blocks in position to mesh with the retaining bracket, and then tighten the top nut securely with a wrench. Repeat with at least one other bracket spacer combination. The goal with the bracket and spacer is to have the bracket as level as possible to best secure the part. Determining the position of the edge of a part is done with an edge finder. Treat edge finders carefully. They are easily damaged by abuse. The edge finder is spun by the mill head, usually in the drill chuck, and the part is moved slowly against the edge finder. The finder will at first quit wobbling, and then at the precise, reproducible location, the edge finder will make a noticeable sideways jog. The desired position is right at the transition from no wobble to jog. This is the front view of the transition from wobble to no wobble to jog. The bottom section of the edge finder has a very precise diameter of 0.200 inches. So when the edge finder jogs, the part is 0.100 inches from the exact center of the quill. The digital readout can then be zeroed by pushing the desired coordinate button, either X or Y, entering -0.1 and pressing P. The procedure can be repeated for the other coordinate direction if desired. There are several types of holes or slots that can be drilled and milled into a part. A drilled hole, a threaded hole, a milled slot, and a reamed hole. Any of these can also be countersunk. Most hole types begin the same way. The starter bit is placed in the drill chuck. The starter bit is relatively thick with a small drill end sticking out. It will not flex when the hole is started, so the position of the hole is quite exact. The starter bit is used to drill a pilot hole, which is a short hole used to guide a full-size drill bit into the piece. You advance the bit with the quill downfeed lever. After the pilot hole is drilled, you put the drill bit corresponding to the desired hole size in the chuck. You then advance the bit with the quill downfeed lever. It takes patience to drill a hole. Use a moderate, steady pressure. The depth of the hole is measured from the face to the end of the full diameter section. It is not measured to the deepest point in the hole. Using more bits than the starter bit and the final diameter bit to drill a hole will usually make the hole walls less smooth and make the hole axis less square. Do not use a series of bits to drill and enlarge a hole. On a through hole, always stop before you start drilling into the vise, the table or the spaces. For precision holes, you may want to use a reamer for the final hole diameter. Contact a proctor or watch the lathe video for instructions on reaming a hole. A milled slot is usually started with a drilled hole, but a center cutting end mill could be used for the initial hole as well. The chosen drill is usually slightly smaller than the desired slot width. The end mill is plunged into the hole to the hole's full depth. The mill is then withdrawn. Part is translated horizontally a small distance, typically a few hundredths of an inch, and the mill is plunged in again. The process is repeated until the slot is the desired length. The milled part often needs to be filed to remove any metal burrs or rough edges. Use care and patience when filing to avoid cutting or abrading yourself. For a tapped hole, first drill a pilot hole with the starter bit, then use a drill bit slightly smaller than the final tapped hole size. Finally, use a tap and a spring-loaded tap guide to tap the hole. The tap guide holds the taps centered on the hole and perpendicular to the part. While tapping, do not turn the mill on. Great unpleasantness will follow if you do. Lower and lock the quill and use the tap guide to apply a small amount of pressure on the tap. Then screw the tap into the part. You should use a small amount of tapping fluid to help the tap turn easily. As the tap enters the part, be sure to keep the tap guide in contact with the tap to keep everything square. When you're finished, be sure to clean up the mill. Vacuum up any loose chips or cuttings, and return the end mills, drill bits, spacers and other tools to their proper position on the table.